All right, we are going to get started here. We still have some guests joining us, but we will kick it off. So thank you to everyone for joining us today. Good morning, good afternoon, and good evening, depending on where you are in the world. My name is Alex Nelson, and I'm a marketing manager at Rivery. We're coming to you from our home offices today, and I'm pleased to welcome everyone to this live webinar session. So first, I'd like to introduce our speakers for today. We're joined by Dan Greenberg, Partner Growth and Operations Lead at Rivery, as well as Taylor McGrath, Head of Customer Solutions at Rivery. To quickly go over our agenda, we're going to get started with a quick poll here for our guests, and I'm going to provide a brief overview of Rivery before handing it over to Taylor and Dan, who will be discussing the 4 key steps for successful cloud data migration. This will then be followed by a live Q&A session. And just to point out, please feel free to send your questions via the Q&A panel at the top right of the screen during any time throughout this webinar. So with that, let me provide you with a quick intro to Rivery. Rivery is a cloud-based data integration platform that enables businesses to consolidate, orchestrate, and manage company data. To improve ease of use and the speed of implementation, Rivery is platform agnostic, which means Rivery is compatible with the platform of your choice, including Amazon Web Services, Google Cloud, Snowflake, and Azure. The platform is designed to consolidate all of your data sources under one roof, as you can connect data from any source. There are more than 90 API connectors to third-party data sources that are currently available for every user, and this helps to cut down on time required by data teams to aggregate their sources. In addition, Rivery offers an API on-demand program, so if there's a data source required that isn't currently available, Rivery can build it for you. The platform is also built to accommodate any size in terms of data volume. For flexibility and scalability, Rivery uses a consumption-based pricing model, so you only pay for what you use. Lastly, Rivery was made to be simple. A number of out-of-the-box solutions allow data teams to easily streamline data sources and insights in the cloud. With automated features and plug-and-play options, teams can be set up and running in a matter of clicks. Hopefully that provides a brief introduction to Rivery as a platform and how we help companies find success with their data. At this point, I'd like to hand it over to Taylor to begin our main discussion for today.
All right. Hi, everyone. I am Taylor McGrath, and I lead the customer solutions practice here at Rivery. Prior to this role, I worked in the data analytics space, where the bulk of my experience was in end-to-end data projects, including integration and data warehousing best practices, and enabling self-service data analytics across organizations. So today, I first want to set the stage and define what the scope of a data migration to the cloud will be considered for this session. So we are defining a data migration to the cloud to be the process of both moving data to the cloud and leveraging the capabilities of a cloud computing environment to store and use data in an optimal manner. I also want to touch on the why, or the most common reasons for performing a data migration to the cloud. So first is with a cloud native data warehouse, you'll have built-in maintenance options. So with a traditional data warehouse, resources are required for maintaining the infrastructure to host software, hardware, and networks, creating redundant systems to ensure you don't lose data. And all of this requires hiring and training in-house IT experts to maintain and secure these systems. Next is the quality or best of breed. So cloud service infrastructure affords you flexibility and the best of breed equipment in the industry. So the newest high-end processors, most optimized memory, SSD storage, and in addition to all this, just that being programmable as well. Probably the most common, one of the most common reasons for migrating to the cloud is performance. Often companies using conventional technologies to handle the high volume, velocity, and variety of data encounter delays in system response time. This leads to poor performance at the level of the database cluster, and consumers end up abandoning downstream applications that utilize the system. So to address this problem in the short term, businesses end up over-provisioning, increasing the overall cost. Cloud platforms allow for auto-scaling depending on load size, as well as the ability to compartmentalize compute and storage for different use cases or different groups of users. Cloud service providers must meet the highest security standards in the industry set by health, financial, and government institutions. This makes it easy to obtain certifications like SOC 2, HIPAA, GDPR. Further, options for authentication, authorization, logging, auditing are all also built into all these cloud platforms. And lastly, pricing. So native cloud systems offer various ways to go about pricing, many of which are pay-as-you-go models or much more flexible and usage-based models than traditional on-premise agreements. All right, so now that we have defined what a cloud data migration is and why we would want to migrate, we want to ask, how can we ensure that our migration is successful? So the first step of our 4 steps to a successful migration is define what that success means. So at a high level, it's first important to know what you have. So deeply understanding the complexities of your current state. So that is assessing your current sources in terms of data size, data format, data location, your data relationships. So it may be that there are multiple architectural layers with hundreds or thousands of tables, relationships, and data transformations representing a very large investment of intellectual effort. So if you're lucky, the business and technical requirements that drove the implementation are well known and clearly documented. Next, we want to establish a time-based goal, a quick win. So how quickly can we get data to the cloud and show value with that data? And then lastly, migrating to the cloud it's more than just replicating what you currently have on-premise to the cloud. It's first doing this and then incrementally converting or redesigning your data model to adhere to the strengths and capabilities of your cloud data warehouse. Thus, the approach for migration to the cloud is broken into 2 streams. The first being an as-is migration, or replication of an on-premise database to the cloud. This includes replicating the data and metadata, automating this process for future data refreshes, and swapping the connections of downstream dashboards and applications to pull from the new cloud data warehouse. But this is only the first piece of the puzzle. So to truly migrate or transition this workload to the cloud, you'll need to redesign your existing data model to best utilize the capabilities of the cloud. So the second and longer phase is what we're calling incremental data model redesign or conversion. So next, we'll take a bit of a deeper dive into both of these phases, starting with the first phase, the as-is migration. So this is what we can consider and evaluate as our quick win of migrating to the cloud. And that's because the steps involved are largely plug and play, and we can leverage best-of-breed softwares or tools to quicken this process even further. So the first step is the replication itself, or copying the historical data and metadata to your corresponding cloud data warehouse. After this, you want to set up an ongoing pipeline or orchestration to continue to pull in new data and keep your cloud data warehouse up to date. Once data is loading regularly, since this is in the exact same structure as your traditional system, it should largely be lift and shift to rewire your dashboards or BI tools to pull from the new data warehouse. And again, this can be sped up by leveraging tools to quickly conduct the replication, create the pipelines, and automate data validation between the old and new warehouses. Specifically for this as-is migration phase, you'll want to think about how you perform the replication itself. So typically there are 2 different approaches for performing a database replication. One is change data capture, or CDC, and the other is loading incrementally in batches at a certain frequency. So to quickly define CDC, for those who may not be familiar, is a process that reads data and metadata changes from the source database's logs. There are some advantages and potential drawbacks to using CDC. So for the advantages, it's the ability to perform a quick one-touch sync to the cloud. Metadata changes such as deleted records are kept in log form, so it is entirely auditable. Also, metadata changes are synced automatically, so there is no manual effort for schema changes, such as a new column or a changed data type of a field. As for potential disadvantages of CDC, it will require certain skills and knowledge to set up and prepare for. The changes are pulled from database binary logs, not the tables themselves. So these logs have to be maintained and have to be accessible, leading to wider permissions on the database itself. So this really comes down to a matter of what the use case requires long-term and the resources available short-term to initiate the configuration. Next, we'll dive deeper into the incremental redesign phase. This is after you've performed the as-is migration and improved initial value by porting dashboards or BI tools to this new cloud data warehouse. In the incremental conversion phase, you'll want to incorporate a bottom-up iterative approach to your conversion process. So subject areas of your data warehouse can be weighed by their conversion benefit. So for example, if a certain domain consumes a large percent of the existing database storage capacity and a decent percentage of the more frequently used queries to access the data, then migrating the subject area off of the on-prem system first will not only provide cloud data warehouse benefits to the users, but the remaining users of the on-premise database experience better performance due to the new capacity available in the meantime. So with each subject area, you'll want to assess the current data model of that area and what needs to be changed in that data model. Then, if possible, you'll build pipelines from the source systems themselves, eventually cutting out the middleman of the on-premise system. You'll then rewire the connections to downstream applications to pull from the new data model of the subject area. Just a note, after the redesign of the data model or the data model of a certain subject area, a redesign of certain dashboards or means of consumption may come into play. So it'll be up to the requirements or restrictions of the use case to dictate whether this step is merely swapping connections of existing dashboards to pull from the new data model, or an opportunity to optimize the views feeding your downstream applications. So next, I want to get into a bit more detail with what is meant by redesign your data model for the cloud. I think it's one of those easy things to say and recommend, but a lot more complex to actually implement. So first, to summarize the goal of the redesign process, short and sweet, it's to balance your compute and storage optimization with simplicity of consumption. So on the technical side, you can optimize capabilities of the cloud by storing data in a less structured, less relational format, utilizing repeated and nested field types. However, this does not optimize ease of use for end users or BI platforms. Many end users may only have basic SQL skills, so pulling and wrangling and parsing your nested or repeated data structures will not be in their wheelhouse and will not result in your highest rate of adoption. Thus, the physical design approach should aim to optimize this ease of use for as many business use cases as possible, but also recognize that physical schema optimization for query performance and cost may be needed in certain situations. So for example, many cloud native data warehouses can be optimized by using nested and repeating fields to flatten multiple tables into one table to physically co-locate the data and eliminate required joins. An example of this could be combining dimensions at the same granularity as the fact with fact table data to flatten it. So in this case, descriptive values at the fact level granularity. I like to call this like a star schema light, since the data is flattened into structured format, and dimensions at different granular levels can still be kept in their separate dimension tables. And finally, taking all this into account, we still want to adhere to data warehouse design best practices in regards to separating physical areas of our data to first, store the data in its raw format from the source systems, and a second area to act as a central location for transformations such as flattening, performing joins, and then lastly, a semantic or reporting layer that's linkable to your business glossary and other data governance artifacts. So this area will feed the basis of your data consumption. All right, so now that we've established how to define a successful migration in terms of success criteria and the approach, we'll cover the considerations needed to evaluate and select the right tools to help us perform the migration itself. So when performing a data migration to the cloud, you may need to repurchase software, re-architect your data, and determine which software to keep, which to get rid of, as well as decide on any new software or tools to use to perform the migration itself and keep these ongoing processes running. So these are big decisions, and there are a plethora of options out there. Thus, before deciding which stack to move forward with, there are some considerations to factor in. So firstly, I'm just going left to right here. Firstly, you want to think about the extraction method of your migration, what that calls for. So if CDC is a non-negotiable, then the tools you're evaluating must be able to comply with that requirement. There may be a question of using a SaaS ELT tool or versus something user managed. So if you're evaluating SaaS tools, you may require that that platform be able to run on a certain cloud provider, or that the tool possesses certain compliance certification, or supports something like AWS Private Link, where you can have a secure tunnel from your private cloud to the cloud of the SaaS platform. I think, just a plug, we do have a poll that's popped up, so feel free to fill that out or not. Next, with cloud software's pricing models being some form of pay-as-you-go or subscription, in this case, time truly is money. So for business value, this may just be the most important thing to consider, not just which tool is cheaper or cheapest, but which pricing model works for this migration's specific needs and will scale with the organization's larger data needs in the future. So for many migration efforts, or really any cloud data orchestration in general, you'll want to think about the degree to which you want to automate deployments and assess which tools or vendors supply the programmatic capabilities to perform these tasks, and also to track these tasks with a form of version control, whether that's managed in the platform or integrated with external version control options such as Git. Next, you do want to scrutinize the scalability and flexibility of the vendors you are choosing from. So I really can't stress this enough, especially in a time like today, that things can change quickly, and you never know what the state of your data environment requirements will be in the future. So you want to think about how increases or even decreases in data size and sources will be handled in said tool. So what's the effort to scale up a user? What's the manual effort to add a dependency, to expand a transformation to a new table, et cetera. And lastly, determine the user management and permission level needs for these processes. So for example, if your migration is part of a larger solution that requires multi-tenant support, that should weigh heavy in the tool selection process. So throughout comparing tools and documenting trade-offs of the various considerations mentioned, you'll want to think about your overall tool overhead. So is there a tool out there that covers all of your needs of replication, orchestration, and transformations? In addition, the current state of your environment will likely not be the same in 6 months, in a year, 3 years. You want to assess tools with scalability at the forefront. So especially things like pricing, deployment, and the ability of transformations. So after you've narrowed down your list of potential tools to move forward with, you want to truly evaluate these options in a proof of concept or POC. So at this point, I will hand it over to Dan Greenberg to talk through that process.
Thanks, Taylor. So we're now going to move into a discussion on how to optimize and showcase business value. First discussing the approach to a successful POC, and then moving into a discussion around scaling to production. In the POC period, there are several topics that should be considered to drive the most value given the tools you've selected. So first and foremost, what's the approach? What's the minimum we need to prove that the solution works for your organization in question? You don't need to spend a ton of time loading everything historically or doing extensive data quality checks. When you start small and scale as needed, you're able to focus on value over complexity. And this is a theme that I'll be revisiting throughout the presentation. Next up is resources. So it's important to define upfront who are the resources in the initial POC exercise when developing the MVP. You're also going to want to consider the resources you'll leverage if and when the solution scales. While they might not be directly involved in the POC at the moment, it's important that they stay informed on the progress of the POC. Ensuring resources selected that have the right skill sets is also very important. You want to define what the data is and how much data you want to migrate in terms of scope. So internally, align on the extent of the scope based on business value and be very specific on what that is. For instance, there may be 5 relevant sources and you only want certain tables from each source, or maybe there are 5 sources and 2 are more mission critical. And as a result, the tables from that source are all you need to get to the MVP. So decide on what that scope is up front. Next up is success criteria. So determine what's the most important thing to see working in action in the POC. And note here that each phase of the migration will likely have different success criteria and that different organizations can and will prioritize success criteria differently. POC progress should be checked against these predefined success criteria on an ongoing basis. The last thing to consider is timing. So adherence to a timeline for the POC and the decision-making process is paramount to achieving business value in the most efficient way. So you want to set a timeline early and communicate it with both the internal teams involved and the involved vendors to ensure that there's proper expectation setting up front. So running the POC. At the end of the day, the POC exercise is meant to validate the efficacy of the solution you're evaluating. As such, you need to prove out proper business value without getting bogged down in complexity. So the POC should address both phases of the migration. So in phase 1, the goal here is to see replicated data in action. So based on the scope, replicate the entirety of the agreed upon data, which could be a set of tables from the database, an entire schema, or some other quantity or amount of data. Next, rewire the certain business BI or applications to show the replicated data in action. Simultaneously, the POC period should also cover part 2 of phase 2, which is geared toward an incremental conversion of your pre-existing data model. We suggest redesigning a single business domain in the POC period. This business domain should not be overly complex, as this will promote quick time to value. The redesigned ETLs will pull directly from source systems, and the new data model will replace the as-is replicated data from the on-prem database. Dashboards and BI should be reconfigured to pull from the new data model for the chosen business domain. So now thinking about POC to production and what are the implications at scale. So a couple different areas to consider here. So the first is new domains. Your organization should look to iteratively onboard additional domains to the new data model. It's really important to consider what resources might be required to accurately judge the level of effort to scaling the migration. As these additional domains are added to the data model, it's also important to plan for sunsetting pre-existing ETL flows that are no longer relevant. The next area to consider is budget. So you want to ensure that your organization can support the cost of the migration in both the current and future state. Consider what costs may look like at certain points down the road, given your selected tool stack. As you grow data and user-wise, you also want to consider how this affects your ROI. The consideration is not just the cost savings of being in the cloud, but also the data-driven insights and value your organization will realize in front-end BI and applications that leverage a best-in-breed cloud data warehouse. The next area is permissions and user management. So different user groups will likely require different levels of access in the chosen tool stack for the migration. There should be foresight and planning into these relevant accesses up front. Certain source systems may also have security restraints that limit user access, and these constraints should also be taken into consideration when planning for the rollout of the larger migration project. The last area here is new processes. So similar to any new initiative or routine, there will be required processes to manage the migration initiative at scale. And pipeline development and deployment to production are two paramount processes that should be actively managed and planned for, as these processes form the backbone of any ongoing cloud migration. Another really important thing to consider is the vendor relationship. So you want to assess what the vendor is like. For instance, what's their customer support like? What's their success team like? How's their overall communications? Part of the POC period is to gauge what it's like to work with the vendor or vendors you've chosen. So it's really important to make sure you do your due diligence here. So all of these considerations should ultimately factor into this decision on whether you want to continue scaling and continue going with your cloud migration. So step 4, the best practices for an organizational rollout. At this point, you've decided to move forward with the cloud migration initiative, and you want to know what's next. The first thing to consider is build versus buy. So does your organization have the resources to build the solution in-house? If not, external services providers can be contracted, and there are a multitude of different experts in the space of cloud migrations that one can consider. Onboarding users is the next thing. So different users will have different levels of responsibility in the migration initiative. It's important to onboard users as their roles become relevant. Third, the synergies between data silos. So cooperation between data silos helps ensure an optimal working process in the migration. Consider how functions might overlap and use this as a point of strength. Next up, training resources. So it's really important to arm your organization with the resources and collateral that describe key tenets for ongoing success. This becomes especially important if people leave your organization or join your organization during the migration project. So don't assume that people know what to do. And then lastly, communication. So there should be top-down support and communication of that support for the migration initiative. It's important to continually update on the status of the migration over its life cycle to ensure organizational alignment and proper support in that direction. So all in all, we see 3 common themes that can help any organization create and sustain long-term success in cloud migrations. The first thing is simplicity. So the solution should be intuitive and facilitate ease of use across user groups. The sort of second key theme here is flexibility. So the solution should allow for adaptability for the ability to make changes and edits over time to the solution. And third, the solution should be scalable. So it should allow for growth in terms of technical capacity and the cost implications of working at scale. So taking these 3 themes into consideration with the rest of the strategies discussed today will put your organization in a great position to recognize the benefits of a cloud migration initiative. That's all I have, and now I'm going to pass things back to Alex to lead the question and answer session.
All right. Thank you, Dan and Taylor. We are now going to open it up for questions and answers. We've got some questions here in the pipeline, but if anyone has additional questions, the Q&A panel is still open. So feel free to send those through at any time you like, and we'll do our best to get those answered for you. So I'm just going to go in the order these were received. So Dan, I think this is probably a question for you, but the question is, what is the best way to request a custom API build?
Yeah, so in working specifically with Rivery, I think it's important to basically stay aligned with, your relevant contact, at the vendor. Basically, having custom API builds requires certain pieces of information out of any API for any team to basically investigate what the process would be, for building a pre-built integration, and ensuring that you stay in communication with the vendor during the development process makes it very clear which endpoints are important to expose, and so that the API build is very tailored to the actual, customer in question.
Great. So the second question we got here came during the phases slides that you were presenting, Taylor. And the question is, how long would you estimate an initial as-is migration would take for a middle-sized tech startup? Who in the company is typically responsible for building these pipelines and rewiring the connections?
Yeah. So in terms of length of time, the goal of the as-is migration is ultimately to act as a quick win, thus be as swift as possible. And there are tools that make that very simple. Just for example, with Rivery, all of the metadata of your source database can be like detected and replicated in a single process. So depending on how much data, not necessarily the size of the company, that will dictate, how long the historical load takes. After that, it's simply a matter of scheduling this process to refresh at whatever desired frequency. And then you can leave that running while you start your data model redesign. So all in all that, once that connection is established to your source database, this shouldn't take more than a couple of days to make a replication, some refresh processes, and perform necessary quality checks. In terms of who in the company is typically responsible, this may depend on your company size. So for like a larger enterprise corporation, you would likely have a team specifically for this on the IT side, where for the smaller mid-sized companies, it's likely just you're a data analyst or data engineer who will be maintaining this.
Great, thank you for that. Going on to the next question here. When do I know that I'm ready to sunset my old database? For how many weeks or months do companies run them, both in parallel during the transition?
Yeah, so it's a bit of a tricky one because in reality, this may not happen for a while, meaning sometimes sunsetting a database completely is not the ultimate goal of a migration. It's simply to move the center of gravity of a data environment to the cloud and alleviate users and processes from the performance struggles of the original on-premise system. So thus there are times when companies run on-premise systems and cloud data warehouses in parallel for months or even years if the bottleneck no longer exists. In other cases, let's say due to budget, it definitely may be in the interest of some organizations to completely sunset certain systems. So this should happen, again, in an incremental manner in line with your incremental redesign, and backups of the system should definitely be taken as a safeguard. But I'd say you're truly ready to sunset a subject area of your old database when all the consumption has been migrated to the cloud solution and there are no longer any dependencies on your old database as a source. So you can do this incrementally until it's no longer needed at all.
Great. And we have one more question in the pipeline here. Again, if anyone has additional questions, the Q&A panel on the top right is still open. Dan, this is probably a question for you. In terms of organizational rollout for enterprises, do you recommend migrating all data at once or doing it gradually based on the departments and teams and their respective data silos?
Yeah, it's a great question. So I think we recommend, the incremental approach to these migration initiatives. So it's important to understand the order in which departments or teams should be addressed in the migration. And this ties back to the concept of balancing business value with complexity, right? So looking to prioritize those departments or domains where the data is most mission critical for users, while also considering the complexity of, replicating and rewriting ETL flows for that specific domain, as I think something to consider as you're trying to, determine that incremental approach. So.
Great. Well, I think that concludes what we have from a Q&A standpoint. If anyone does still have questions that they'd like to ask, please. Oh, I think we have another one here. So the question is, how does Rivery help a migration project or make it easier? Bit of a large question, but Taylor, Dan?
Yeah, I can jump in here. So Rivery can act as the means of the integration element of a migration project and also as an orchestrator of transformations, right? So in phase one, the as-is migration, just like getting a replica of your database to the cloud. We have a functionality called auto migration, where essentially you just connect to your source system. It'll detect the existing schemas and tables, and that is all wrapped in a single process. So that can happen in a matter of clicks, and then that can be scheduled so that ongoing these updates are made, whether that's incremental loads or CDC. And then after you have your data running and refreshing, there is a whole logic component of the tool as well, where you can have essentially push down transformations in whatever cloud data warehouse you're using. And then these can be built into workflows with dependencies, so that these only run once your data is fresh. So for kind of both phases there of a migration, Rivery can help to migrate the data itself and kind of orchestrate that incremental redesign of your data model.
Great. Thank you so much for that. Again, if anyone does still have questions that they'd like to ask, please feel free to post them in the panel, or you can reach out to us at contact@rivery.io, and we'd be happy to get you an answer. Additionally, we're going to be conducting more webinar sessions moving forward. So if there are any subjects or topics that you'd like us to cover, please let us know. And real quick here, it looks like we have one more question. So we have a little bit time left, so we can go ahead and get those answered. This question is, can you explain a little more of the incremental loading and how it deals with updates or deletions of data records?
Sure. Yeah, I can take that one too. So incremental loading, meaning you're not using CDC. So the option there so the way that works is essentially you can set a loading mode that is, say, like an upsert merge with some primary keys or whatever desired primary keys, meaning that only new or changed data will be loaded into your target tables. However, that won't reflect, like, say, if something is deleted on the source side, that won't be reflected in your target. To do that, you would use the CDC option, because that has a full log of kind of every change that's made across your database tables, metadata-wise. So a log of everything that's deleted will also be available to you. And then essentially there's options to either perform those deletes, hard deletes or soft deletes. So hard deletes meaning the deletes will be reflected in the target tables. Soft deletes meaning they will just be marked as deleted, and then you can handle them how you see fit in your target data warehouse.
Great. And it looks like we have time for about one more question here. So the question is, for initiating a planned migration of workloads and assets to the cloud, do you use your own tools for the desired outcome?
Yeah, I'm not quite sure what this one means.
Okay, well, we will be sure to follow up on that and get you an answer, John. And I guess just to follow that up, we can do one more question here. So how does Rivery handle changes in the source? Is the destination schema changed?
Yes. So yeah, the case with CDC, the destination schema will be changed to reflect that of the source. So essentially, if like a data type of a column is changed, we'll detect that upon the runtime, and then update that in the source.
Great. So thank you, everybody, again, for all your questions and taking the time to join us today. Stay safe, and thank you again to Dan and Taylor for a great presentation.